evening, everybody. Looks to be very, very interesting and fun event, but I appreciate the possibility to give this presentation and join at least over the online session. And yes, indeed, I will be talking about implementing this RED specification and cybersecurity in practice, and I will show pretty much practical approach with some examples how we are implementing the cybersecurity. Yes, so just before I go to the subject matter, let me just quickly introduce SATEL. So we are a wireless connectivity provider from Finland. We are based in city of Salo, which used to be the old Nokia and Microsoft city, but still there's a huge amount of wireless connectivity know-how present in that city. It's a middle way of Turku and Helsinki. We have been manufacturing these radio devices since 1986, so we have close to 40 years of experience with this topic, and we operate globally. We are represented by global distribution network, and with some biggest OEMs we operate directly. So we work with the global scope. Here you can see some examples of our products. So these connectivity units, they are designed and manufactured here in Salo, and some of the products are this kind of a size of a matchbox, which can be installed inside the device, inside the vehicle display, or as a part of vehicle systems, or precision positioning systems inside the system. And then we have these entire radio modems. We have strong protection. We have ingress protection and protection against elements, against dust and moist and so forth. And here on the leftmost product is actually our latest launch, where we are including LTE connectivity, Wi-Fi connectivity into the same casing with traditional UHF radios. So these UHF radios are serial connected classic radio modems that don't require any SIM cards. They connect from antenna to another or from antenna to multiple receivers. So it's a local isolated network classically. But as I mentioned, in our newest products, we have LTE internet connection and Wi-Fi. So certainly these new cybersecurity requirements are something that we cannot take for granted, something that we need to focus on. And this may look familiar to you from previous presentations, for example, from Joachim's presentation. I just want to highlight that for a company like SATEL, that we have been providing wireless connectivity for almost 40 years, being compliant with the requirements and standards. It's nothing new to us, and for the industry, it's nothing new. So we have had to comply so far to radio standards, electromagnetic compatibility standards, safety standards. Now with this new situation, and as per the topic of tonight's presentations, there's, let's say, yet another standard and compliance that we need to meet the requirements of. So cybersecurity compliance. Okay, I gave you a brief introduction of SATEL products already, and I think from the compliance point of view, it's also important to divide our products into two categories. We have those classic radios that operate within their own isolated network, and then we have this mission-critical machine connectivity product line, which are providing connectivity for off-highway machines like those of smart agriculture, mining, construction equipment. Just to highlight the focus on where SATEL products are focused on, you can easily see from this picture that we are focusing on very business-critical applications where the industrial process is valuable for the customer and the user of our devices. And basically every second of downtime has a certain high cost. Now, if we think further about these serial connected devices, those with the isolated network, they are not connected to the internet by default, and way how we see it is that the RED 3.3 doesn't apply to these products. Even the front page of the standard says that common security requirements for radio equipment internet-connected radio equipment. But of course, still, even though the standard doesn't apply, it doesn't mean that we would forget the cybersecurity and security aspects. We have encryption, we have multiple different security features there for this product line as well. But then the other product line, the mission-critical machine connectivity product line with Wi-Fi, cellular, and so forth, where the vehicle connectivity is provided by SATEL. You can see that the SATEL router is on the edge of the vehicle network. So that gives a certain responsibility for SATEL, being the gatekeeper of the vehicle network. And also that implies directly that we have to comply with the RED 3.3 requirements. Okay, then another aspect. I noticed or introduced the SATEL product line of radio modules already. So these modules are something that our clients can integrate as a part of their systems, their display systems or something like that. And now how we see it is that because we provide something that is part of the product, then the final customer who's implementing the module as a part of their product, they have the responsibility of doing the certification from the radio equipment directive, whether it's the radio or the cybersecurity part. But also in this case, we have to bear in mind that why we are doing this, why we are providing the connectivity units in generic, and why do we call our connectivity units mission critical? The connectivity units for off-highway vehicles, they enable important industrial process like data sharing, sharing the process information on the construction site. It enables the accurate 3D machine control, model-based building. There are even standards from ISO family like 15143-3 and 4, which describe the telematics for earth-moving machinery. There's no use of this kind of standard of telematics for off-highway machines if you don't have the connectivity that delivers the telematics. And now when the autonomous operation is enhancing all the time, if there's evolution ongoing, this role of connectivity becomes more and more important because we need to have more mechanisms to monitor the operation of automated machines. And as a step in the evolution, there's a step of assisted autonomy. So remote control needs to be somehow activated over connectivity. So connectivity plays such a vital role there in the industrial processes that we are not doing the cybersecurity because of the certification requirements, because of the RED or Cyber Resilience Act, but we do it because we want to provide our clients reliable and robust connections. Okay, if we follow the standards of 18031-1, which is the standard applicable for SATEL products to meet the requirements of RED 3.3. If you look at the contents table, this is public material. This is taken from this is available in the internet in multiple review sources. There are very important topics there, like secure storage, how to update the devices, how to make sure how to do traffic control mechanisms, resilience mechanism, how to do authentication. It would take, and I would be happy to present you 1 hour or even longer presentation of how SATEL is enabling all of these things. But because we don't have time for that, I would like to highlight just a couple of, let's say, interesting. I cannot say that some of the topics are more important than others, because the whole topic is important, but I would say that interesting. And at the same time, I have to say that even though this RED 3.3 is requiring this standard 18031-1, there are many other standards like 62443. I think it was mentioned by Joachim in the reference of Cyber Resilience Act, because in this Cyber Resilience Act, you can basically select to follow this standard. So I think this standard brings the security requirements even more practical level. So when we want to secure our devices, I would say that 62443 even more enhances the requirements from RED 3.3. And actually, in upcoming slides, I have copy-pasted some snippets from the content page of the 18031. But this snippet here, you can see that in this standard, there's also a mapping presented between the requirements of the 18031 and the requirements of 62443. Although the standard says that if you comply with 62443, it doesn't mean that you would comply with the other one. But there's a certain mapping there, and I think this one enhances the RED 3.3 standard. And when I want to present these examples from the standard, what are our solutions and how do we comply with the standards for these particular features, I decided to follow this one classification criteria of CIA, classification of these security features. And I like this classification because, from my point of view, it highlights the most interesting ones in the specification, and those are confidentiality, integrity, and availability. And I'm not sure if it's a coincidence or what that the letters form acronym of CIA. First, confidentially. So a couple of examples from our products that how do we tackle this confidentially. And also at the same time, it is partly providing integrity. Also in this mapping table, you can see that these many topics, they are cross-referenced and cross-related to each other. So our confidentiality and integrity. So in our devices, we implement this secure element, which is a hardware chip that can secure way store certificates, keys for authentication. That is an authentication and the access management. These keys can be used for all of these three: network confidentiality, so securing the connectivity, enabling secure boot of the device so that the device can make sure that it is always booting the legal and valid and integrity-enabled firmwares. And also, when we are doing the updates of the product, we want to make sure that the update file is still maintaining its integrity, and it is the actual update file that is originating from SATEL. So these secure keys can be also utilized to verify the confidentiality of the files. And here again, snippets from the table of the RED document. You can see that these topics are addressed in the RED document. Then availability, and I think this availability is example of how RED 3.0 provides only the minimum requirement. That is actually the same stuff for EMC requirements, for example. In many aspects, our radio interface is much better than the standards requiring compatibility with EMC standards. And same I would like to say for cybersecurity as well, that where the RED 3.3 resilience mechanism only addresses protection against denial of service attacks. I would like to see that when we want to provide available and robust connectivity solutions, we have to provide resilience in much wider scope. And how this resilience can be achieved is by careful network planning, or for radio signal and antenna planning. Devices must have a robust power supply. You could even provide devices in redundant manner so that if one device fails, then the other one would take the action. The products must have a certain build quality in them, which can be then monitored by mean time between failure figures. All of this together add up in a generic availability of the connectivity. And one could even say that what is the use of cybersecurity if you lose the device of you are protecting? So then the topic of cybersecurity basically loses its meaning if you don't have the availability of the device there. I did show this slide before, but this is actually quite clear example of how to implement the requirements of 18031. Traffic control mechanism is specified in the standard, and when the gateway is on the edge of the vehicle network, that is a very logical and down-to-earth position of the firewall, and that is a very logical role of the device to manage the whole security of the of the network behind it. And then these traffic control mechanisms really need to be in place. Okay, another requirement from the 18031 is up-to-date software and hardware monitoring for vulnerabilities. There's this common vulnerabilities database, which is a public database, and this is how we implement this feature and this requirement. So we have both automated and manual monitoring of this database. And if we find out that there's a vulnerability of any software component that we are utilizing here in our router, there will be an alarm. It could be alarm from a human intervention if some of our engineers spot this, but there's also an automated process. So it works basically 24/7, this monitoring of the vulnerabilities. And if this vulnerability is found, then an alarm will be raised and we will start the actions accordingly. In 1831, there's a decision tree how to operate when this vulnerability is found. And based on our process, what we would do, we would, of course, provide a fix to this vulnerability. And as per that standard specifies, these updates can be even automated. Why do we want to provide automated and centralized updates? If you think of this brave engineer starting to run with memory stick through all the construction sites and all the equipment around the Scandinavia, it would take weeks for this engineer to manage the project. Or if we have a bunch of engineers going to the field, that would be anywhere minimum of hours before the machines are all updated. And what would happen during that time? The vulnerability would be there, open, and any attackers could exploit the vulnerability. Also, if you think of this, how much time and effort it would take, and effort, especially the human workforce that is required for this update to happen, there's huge savings that can be achieved by providing this update from the cloud with the one command, even in an automated manner. So this is something that SATEL solution is also providing. We have a cloud service that can apply this over-the-air updates. And similarly, we are doing not only the vulnerability monitoring, but we are also doing remote logs and monitoring the devices for not only denial of service attacks. This is another example where the standard is specifying that monitoring should be there for denial of service attacks. But we don't exclude other reasons for monitoring. So we are also monitoring the devices for overheating, for breach of the firewall, or any other things that they could happen. Maybe the CPU is running too high and memory is getting too low, or disk space is becoming full. So we, again, want to enhance and extend the 18031 standard to meet the really mission-critical requirements from the field. And that was my last example of how we implement the cybersecurity requirements for RED. And let me summarize. From SATEL radio product lines, these private radios, we call them private radios, those radios that operate on local networks, they are totally disconnected from internet by default. Their connectivity mechanism on the wired side is serial connection. So IP traffic cannot be even routed through them. So they cannot connect the internet. So therefore, we are already by nature safe. But then this product line of SATEL that is producing these industrial vehicle routers, they have very important role and logical role as well. Since they are in the edge of the vehicle network, they have the huge responsibility of securing that whole network. And we are happy to take that responsibility. And for sure, we see that our device is much matched with RED 3.3. For sure, we have to meet those requirements, but we see those as only the minimum requirement. How to even more enhance the requirements is by following 62443 part 4-2. And that is actually already making us proof for Cyber Resilience Act, since we heard from Joachim's presentation, this is one of the possible standards. And this classification of CIA gives a nice practical approach and highlights some of the key features of the cyber security requirements. And last but not least, I want to stress that this cybersecurity compliance is not done because of the RED. We are not doing this certification. We are doing this, and basically everybody else should do it also, to ensure that the connectivity remains reliable and the connectivity would be high available and trustworthy. So this way, we could enable efficient, accurate, and safe and uninterrupted productivity. So the end user process where these connectivity devices are needed, that is the thing that we need to protect. So thank you for bearing with me. I hope we have time for some questions.
Yes. Thank you so much, Heikki. Very interesting to hear from somebody who lives within. Questions from the audience?
Typically, you're not running customer software on this device or custom software, but rather your device software is totally under your control, right?
This is typically the case, yes.
Right. So then you have no problem with when it comes to secure boot and who has the certificates for signing the software. In your case, it's always you that sign the software.
I can see where you're going with that. I think we have some cases where we need to think about these problematics that come from the sharing the or using, for example, here in the secure elements, whose keys they should be. Now it is matter of the trust relationship. If we have a system provider that integrates our devices as a part of their system, or maybe the system provider wants to put their software inside our system, it's basically the analogous situation. So there must be a trust relationship here between the system provider and SATEL. So either system provider is providing us their keys, and we would then, during the manufacturing process, when we know that these devices that we manufacture today, they are going for this system provider. So we would put their secure elements that are provisioned already with their certification keys to these devices. That is one option. Or then the system provider utilizes that trust relationship that we have, and then the keys would be signed against the SATEL root certificates, and SATEL would be the certificate authority in this case. So there are some ways how we can tackle that problem. We actually do the same with some SIM cards, for example. If the customer has their own SIM cards, we could install them as a part of our manufacturing process to the units. Similarly, we could install their certificate. This was more like a hardware approach, but I think this tackles the same issue a little bit.
I think that this is one thing that we don't cover that much today here is that when there are custom software running on a gateway or any device, who is responsible for signing the software and who have the private key? And this is really the most critical stuff you have, your private key. And you don't prefer to send the private key to a manufacturer on the other side of the world. And vice versa. So this is a big issue. I think in your case, it's not maybe a big problem, but we can easily see that there are other solutions of generic gateways and stuff like that, where this is a big issue.
Yes, okay. Also one could think this problematic with the idea that this software that is run inside this unit, it is on the same security level as any other component that is inside the vehicle network. So basically we are just forwarding the authentication request to their authentication server in that case. That is another approach. So our router would be just passing through the network connectivity that are required for the authentication procedures.
All right. Any more questions from the audience? Comments? Joachim? Approved? Yeah. Super. Then big thanks, Heikki. And have a great evening in Finland.